Okay, we will try to understand about KServe. So, what is KServe? KServe is an open source platform that is used for inference, means for prediction, and that this actually have the feature of scalability. It support multi-framework. What is multi-framework mean is scikit-learn based models or TensorFlow based models that is based on neural network. So those models can be deployed on this Kubernetes. And why we use KServe? So we will focus on predictive AI only. First reason why we go for KServe is the multi-framework support. It supports TensorFlow, that is neural network based approach, and scikit-learn, that is basic classification which we do on a tabular data, and the intelligent routing. What is intelligent routing here is like in KServe, we have predictor, we have transformer, and explainer. What they do, predictor predict from the model, transformer actually do the pre-processing and post-processing, and explainer give the reason why this model is predicting this. So how intelligently they are routing the request between each component, that is intelligent routing feature of KServe. And advanced deployment is canary rollout. If we want to test our new model to a subset of the user rather than giving the new model to everyone, just to check if there are errors or the slowness in the model, then we can roll back instantly. Inference pipeline is actually like there are multiple steps in the pipeline. So the input of the step one is given to the the output of step one is given to step two as an input. So in this serial mode, they are connected. An ensemble with inference graph means when we have multiple models and they are predicting, and then out of their predictions, we are testing who is voting more for a particular prediction. So that would be our final prediction. That is the advanced deployment we have in KServe. Then order scaling. Order scaling is based on the request pattern. KServe will automatically scale the workload. Model explainability is to understand the prediction reasoning. So it will explain about the feature attribution, like this particular feature has contributed 90% to this prediction. So we'll understand how exactly our model is predicting. Advanced monitoring. Monitoring is if we have like after deployment of the model, we have to monitor the model performance. And for that, we have in the payload, we have request payload, which is as an input we are giving to the model, and the output, which is as a response to the user after predicting from the model. And the outlier detection is if a model is trained from certain range, but suddenly we are getting a value that is out of our range, so that is outlier. And the adversarial detection is actually to um, test our model by being a bad actor so that we can understand its adversarial effect, like how a malicious user will attack on our model. So we can correct it by using this adversarial detection monitoring. And then we have drift detection, that is to actually test our data and the model drift so that we understand if there is a need of retraining. And we have the cost efficient factor also here, because if there is no use, then our infrastructure is scaling to zero, so we are not paying for the compute resources. So this is actually about KServe. And if we understand this, so in the KServe, KServe provides CRD, custom resource definition, for serving predictive and generative machine learning model. What I mean by predictive is the machine learning model which are actually doing the prediction, and generative AI, that is generating a new image or or the text out of the context which we have given. It encapsulates the complexity of auto scaling, networking, health checking, server configuration to bring serving feature to your machine learning deployment. We have API across frameworks. We have pre, post processing and explainability, and we have support for large language model like generative AI, and the canary rollouts and A/B testing. Canary rollout to test first in a specific a small subset of user, and A/B testing is to test two models which is performing better, and based on the performance, finalize we will promote the model 100%. This is a YAML configuration. So in Kubernetes, we have inference service, and this in the inference service we define the framework for which we are deploying the model. So if here you will see that this Hugging Face that is used in generative AI, and the resources we are defining like CPU, memory, or GPU, and the storage URI, that is from where it picks the model from S3 bucket. So this is inference service in the Kubernetes. And what it actually do, like how it works, that is we have one of the init container that we call storage initializer. So what this do, whenever a request comes, or you can say whenever we get uh, uh, what we call that in request, actually we can say a request. So invoked request, whenever we get a invoked request, what it does, it downloads the model, the storage URI which we have given, and then it load it to the container, and it is happening underneath. So this is how automatically this inference service is working for our machine learning model. So this is specifically designed for machine learning for the prediction in Kubernetes. So that's why we use this CRD. And how it works, it provides CRD for serving models on different frameworks, and it also encapsulate means underneath, or it is abstracting auto scaling, it is hiding auto scaling, networking, health checking, and server configuration when we are deploying ML models. So underneath, it is doing all these features configuration for us. So in generative AI, we have Hugging Face large language model, and for auto scaling, we can use KDA. And for in the predictive machine learning model, we have scikit-learn, XGBoost, and for integration, we use Envoy Gateway. And networking is Gateway API. So these are supported runtimes. These are integrations, and these are cloud native integrations. And this Kubernetes, this is actually running on a compute that could be CPU, GPU based. So on this hardware, we are spinning up an EKS cluster. On the top of the EKS cluster, we are running this CRD so that we can um, predict our model. And there are two plane, control plane and data plane. Control plane, it manages the state. That is like it manages the revision tracking. What I mean by revision tracking is when we are deploying the model, the versions to our inference service. So it is keeping a track of the versions, and we can do canary rollouts, like first test among a small subset of users, and also we can test two models, which is performing best by following A/B testing strategy in data plane component. So in data plane component, like the request response API, and support both predictive and generative models. So data plane inference service. This is the core Kubernetes custom resource that simplifies model deployment with automatic scaling, networking, and health check. So inference service is a CRD which is automatically handling, like underneath it is doing auto scaling, networking, and health checks. Inference graph, it is actually enabling advanced deployment with the pipeline for pre and post processing, for ensembles. Ensembles means parallel processing and multi-model workflows. So we have inference graph, and this is the YAML file which we can install to get started with Kubernetes cluster. That is on the top of EKS cluster we are doing. Create an inference service. So this is configuration to deploy a pre-trained model. That is, the model is already been trained. Like the raw data is processed, and then that with that processed data, we are making our model to learn the pattern with the logic which is written in training.py script, and we are just giving the path where we have our model stored, and the container, that is init container, that is storage initializer, that will automatically download this particular model, and it will serve the request based on the payload which is received by inference service. And this is how we are checking the prediction. So this is how the KServe is actually works, and what are the features of the KServe, and what is KServe. Today we will try to understand about KServe and what are its features and how it works. KServe is an open source platform which is used for inference, that could be generative or that could be predictive model, and it has the features like scaling, that is like it will automatically scale, and it has multi-model support. It can support scikit-learn based framework, it can support TensorFlow based framework, and it also intelligently route the traffic. What I mean by intelligently routing the traffic is we have the predictor, we have the explainer, and we have one more component, that is transformer. So transformer is actually doing pre-processing and post-processing. When we say explainer, explainer is actually reasoning why the model is predicting this result. So this is how it is intelligently routing the request among these components, and it is also cost effective because when there is no use, there is no request, it is actually scaling the infra to zero. And apart from this multi-framework, cost efficient, automatic scaling, automatic routing, and these are all the features. Then how it works. So when the user is requesting in a payload about a particular model, so what it does, the inference service has one init container that we call storage initializer. So what is the function of this storage utilizer is to download the model from the storage, that could be S3 bucket, and then from the downloaded model, the container will load the model into into the container memory, and from there the model will run its maths based on the um, we have inference.py file where we have wrapped the model into an API so that it can predict the requested API. So this is how it actually works, and we have other components. That is, one is the control plane, data plane, and inference service and inference graph. So, what are these components? When I say inference graph, um, yeah, inference graph. So it is actually giving giving a concept that is we have the sequence mode. Sequence mode means the inference pipeline, that is like the input we have given to step one, and then it is producing an output, and the output of step one is given as input to step two. So that that interconnection is happening through this inference graph. And apart from this sequence mode, we also have one mode that we called um, the conditional logic. Conditional logic is a switch mode, that is that actually not that um, there is I am trying to remember what was the name. What it does actually, there are three models which are predicting. So out of three model, if two are predicting a same result, then we will go with the majority. Like with the majority of the vote, we will predict the response. This is one of the inference graph where we are running parallelly. So that one is the sequential running of the container, second is the parallel running of the container. Container means it is having the model which is processing the request, and so this is one way. And and what else I have is the inference service. Inference service is which is actually predicting our model by downloading it from S3 bucket. And we also have the canary deployment and A/B testing. So there is a canary traffic weight field in the inference service. What it does, it is like the new model is first uh, we are giving access to the small subset of the user. Once we are good with the performance, then we can give access to everyone to the new model. If there is any delay or any latency or any error, in that case we can roll back to the stable version. So this is about KServe.